Hello, everybody, and welcome to our third webinar of our webinar series for DIGIFED Open Call 3. So today I have with me Omar Veleda from AVL, Jure Trilar from Ljubljana, University of Ljubljana, Marcello Coppola and Antonio Lioneto from ST Microelectronics. So my name is Alice. I work for Blue Morpho. I'm an innovation business developer there, and I work on DIGIFED as we are a member of the consortium on the project. So before we start, as you know, as I mentioned before, today is the third webinar of our webinar series dedicated to the third open call of DIGIFED, which is also the last open call of DIGIFED for the application experiment. Last week, we had one webinar with Isabel Dor and Margarita Volpe for the introduction of the third open call. On Wednesday, we had another webinar dedicated to our networking app, so how to register efficiently to our networking app. And today is the first of the two sessions dedicated to DIGIFED's technical offer. So as I mentioned, we have AVL, ST Microelectronics in France and in Italy, and University of Ljubljana. Next week, on Tuesday, we will have the last webinar of the series to meet the DIGIFED technical partners again, but this time with Ikerlan and BME. Ikerlan in Spain and BME in Hungary. So, again, before we start, you must know by now, but this is the third webinar. It will be recorded and published. On the right side of your screen, you have a toolbox, and you can use the question box on this toolbox to enter all your questions through the webinars, and we will address them during the Q&A session, which will be at the end of this webinar. So as I said, it will be recorded and published, and after the webinars, the slides and the recording will be available and downloadable on the DIGIFED website under the webinar section. So about DIGIFED, before we start on the technical side, about DIGIFED, it's an innovation action funded in the frame of Horizon 2020. It's dedicated to support European cross-border partnership, to help the industry to digitalize their product or services and to help them to reach new markets enabled by cyber-physical systems, CPS, and embedded systems. At DIGIFED, we are 12 partners from 9 European countries. The project is meant to last for 3 years. It started in January 2020, so a bit more than a year and a half to go. The total budget for the project is 8 million, and out of this, 3.9 million will be dedicated to the cascade funding of SMEs, startups, and mid-caps. So as I mentioned, this is the third open call. The goal was to fund more than 40 projects through these 3 open calls. We had a first open call last year in which we funded 14 projects that are running. The second open call is running as well. We had 16 projects selected. And today it's the third open call, and the deadline for this open call will be the 8th of June at 5 p.m. So what is funded through these open calls? They're called application experiment projects. You can have up to 50,000 euros funding, which represents 70% of the costs. You can get technical support by either major research centers or industrials, and you can have innovation management training by us, Blue Morpho. The targeted companies in this application experiments are non-digital SMEs, startups or mid-caps that want to create first product or demonstrator based on digital technologies. Or there are also SMEs, startups or mid-caps already using digital technologies that want to integrate new digital technologies or increase the digital maturity. So as you might know, we have 2 types of application experiments. The single application experiment where you apply with a member of the consortium, which needs to be a technology partner. So I insist, you can't apply with an innovation management partner, you need to apply with a technology partner. and it needs to be cross-border, so you need to apply with someone from a different country than yours. Then we have the twin application experiment, which is 2 companies from 2 different countries, and in this frame, each of you get up to 50,000 euros. The first company would be someone who wants to develop a CPS innovation or need a complementary expertise to validate the concept. And the second company brings the complementary expertise to realize the prototype or to access the market. And in this frame, there is no DIGIFED technology partner involved. In the frame of DIGIFED, third open call, we have a new type of twin application experiment, which is called the low digital twin application experiment. It's only available in this third open call. And in this frame, you have the possibility to request tech support from DIGIFED technical partners. So on this third open call, we will have 8 million total budget available, 3 types of applications, which I just mentioned, the single, the twin, and the low digital twin. We have 10 technical offers from 6 DIGIFED technical partners. And today we have AVL, ST Microelectronics France, ST Microelectronics Italy, and University of Ljubljana, so 4 technical partners presenting their technical offers. You can get up to 50,000 euros per applicant as a maximum of cascade funding, and it needs to represent 70% of your cost coverage. So that's it for me. I will now leave the floor to Omar to discuss the AVL technical offer. Omar, can you hear me?
Yes, I can hear you. I hope you can hear me too.
Yeah, perfectly. Great. So I leave you the floor.
Okay, thank you. So, hi everybody. My name is Omar Veleda. I'm Innovation Manager at AVL, and my main role is related to research projects. Most of those are done in cooperation with external partners. So it's in a way, it's kind of open innovation, which is also why you see me today as a part of DIGIFED. I'm not directly involved in integrated open development platform, which I'm showing you today. I'm not involved on a technical level anymore. But have crossed paths with it many times in the past. So basically, it's a widely used tool in AVL, and I had to deal with it basically when I was still working as a developer myself. I'll provide you with introduction into its capabilities of the platform. And I need to stress, we use it with automotive companies, so we definitely use it for automotive application, but it is something that can easily be ported and used in different domains. So just because you are maybe working in a different domain, that probably does not mean necessarily that you should switch off. Maybe try to consider using it anyhow. So the IODP is supporting process innovation, and if you consider the majority of development processes are more or less influenced by a range of different tools, and these are there's kind of heterogeneous landscape of the tools. So basically you have a full range of different tools that are not necessarily compatible with each other, so they don't necessarily like to talk to each other, and it's not easy to integrate them. And also many of those tools are kind of part of different processes, and very often these processes are also not aligned with each other. So that causes a pain if you're doing the development. Basically, you have different things that don't necessarily wish to work to operate together, and it creates a pain that this platform tries to address. And also, the platform is not the end. The platform as it exists now, this is not the final product, because I mean there is no final product. It's something that's evolving. So just as the processes and tools are evolving, the platform is changing by itself. Another development pain is related to validation efforts of the hardware components which are integrated in a complex system. So basically, the focus of the real individual components tend to lead to validation of real tangible components, and you can only do this when they are development. So this is at the end of the process. So you have a component, you design it, you go through all stages of development, and the only way to do validation is at the very end. Very often that is quite late. So you try to kind of front load your development in terms of validation. So you kind of have 3 aspects which the platform addresses. So you have the heterogeneous tools, you have the unconnected processors, and then the third aspect is that you have hardware-oriented approach and inability to validate things in advance, basically. So as you address these challenges, the platform increases development efficiency through the transformation and development process, and you kind of create a more agile way of development. This is achieved by enhancing the usage of the real components with the simulation models. So platform is kind of used to mix the real and the virtual hardware components or simulation models. So it gives you a chance to have different things. Some of them are tangible things that you can kick at the end of the day when you're not happy with it. Some of the things are maybe bits of software models, and it kind of allows you to put all these things together and test them as you go through different stages of the development, not just at the very end when you do the integration. And also what it does, it connects the processors. So these are not necessarily connected, as I mentioned earlier. And the result is that you have the kind of enhanced and functional view of the end product. So you can create, in a way, kind of holistic decisions at the start of the development process. And this is possible through easy visualization of the complete product, even if individual components are not ready at the beginning. So that's a kind of overview, very high level overview of the platform. What you are probably more interested is actually the different components, because that's something that you might be interested in using in your projects. So that would be kind of more an operational level, and we'll go into those now. So there are four main components. They can be used each one on their own. You do not need to combine them. You can just pick one of them and just stick with that one and do all of your work with that one, depending what your work is. Or you can combine them, again, subject to what you need, subject to what you are developing. The first element is, or the first component is called Model Connect. And this kind of component enables the communication between separate simulation models. So if you have a bunch of simulation models and each one of them is representing a different part of the system, or even different system completely, if you're talking about system of systems, then this Model Connect kind of allows you interlinking of these simulation models to create a functional view of the complete product. The second element is called Testbed Connect. So this kind of takes you one level further towards what our core competence is in the automotive world. It connects the simulation models to the real tangible hardware into a complete system. So in our case, it connects you to the testbed. So you could, for example, you could have, for example, I don't know, you could be sitting in your office and have some simulation models running, and you could have an engine running in a testbed, and you have an opportunity to kind of to control it from your office. For example, it doesn't have to be your office, could be somewhere else, but that's kind of one of the possible use cases. And the good thing here is that you really have a combination, wide range of combinations that you can cover, and it's domain agnostic. So what I said earlier, it doesn't have to be automotive world related. So in our case, it'll be maybe engine or something else that's in a car, but it could be something else that you are dealing with. The next element is Data Connect, and this is the one that deals with the huge amount of data that is created with the Testbed Connect. So it piggybacks on the previous element. If you consider the complexity of the system, and data management simply becomes a real problem. So this is especially the case if you are concerned with data traceability, because you simply generate a huge amount of data. You need to be able to figure out what's going on with it. We could be talking about simple things like, for example, which test result was created at which point in time, under what conditions, and which set of calibration, for example, parameters were, for example, used. So basically, you can trace it back, and you can then understand your result in a better way, or you can create better insights from your results. It kind of really enhances your post-processing. So if you create a huge amount of data, then Data Connect allows you to improve your post-processing analysis. And then the final part that's offered by IODP is the Device Connect. This one is slightly detached from the other three components, but it is still kind of related to it. It is a highly secure data transmission pipeline. So it allows global connection to distributed devices with a two-way communication. So in our case, these devices are commonly vehicles from a fleet or maybe from a group of instruments that I use for vehicle development or testing. And as I mentioned earlier, this connection slowly, this connectivity solution is not really limited to just automotive applications. So in our case, we are talking about fleet of vehicles. You could be talking about a group of some other devices, instruments, products, whatever it is that you are dealing with. So there's not much to stop you from trying this solution in different domains. The two-way communication allows data collection for over-the-air data transfer to the devices. So basically, you either collect the data from the instruments or from the devices, from your products, whatever, or you can, if you would like to do an update of your firmware, you can basically trigger it from one location rather than having to go and retrieve all the devices, all the instruments, all the products, and then do on-site update of the firmware. The final application is open to your imagination. Basically, it's up to you. I mean, this is what's offered by the platform. It's up to you how you can what you can figure out as the best way to use it. So the main idea of the platform is that it integrates into the tool chain or the tool landscape of the customer. So as the platform is open, it effectively can be connected to any set of tools. In principle, yeah, that's a lot easier to say than to actually do, but in principle, you can connect to any set of tools. They don't necessarily have to be our tools. Of course, we use our own tools, but you can also have some third-party suppliers if needed. An integration of the platform is a kind of a gradual progress process, and it comprises of quick and short loops. So you start with the very small specific tasks, and then you kind of slowly grow integration into a larger system or a system of systems. So you kind of build upon your initial design. So it's a kind of, as you would normally do, let's call it maybe not as a minimum viable product, but you start with something small and then you slowly build upon it. Your focus is on the functional view, and this is kind of what is the unique selling point of the platform, so that at any time in development process you can cross-check the compliance with the original product requirements. So at any point in time you can kind of do a simulation. It doesn't matter how many of your components are actually already created in hardware or in software. You can always kind of do simulation and check whether the results of that simulation are compatible with what you originally designed and whether you're heading in the right direction. Aside from this kind of very technical focus, the platform also considers the adaptability of the processes and people and their relationships. So sometimes they need to be adapted, and platform is capable of not doing it for you, because at the end of the day you are the one who has to control what happens there, but platform is capable of actually supporting you when you're doing this. It is a tool, so as any other tool, it will do what you tell it to do. So basically you have to control it, you have to do what you wish to do, and the platform is there simply to support you, to make your life easier while you're doing that kind of change. The application is not limited to automotive domain. I think I already mentioned it probably at least 2 or 3 times. It can cover a wide range of area. For example, in our case, we are using it for optimizing different model variation decisions based on how these complement each other. So of course, in our case, we are talking about vehicles, but if you have variations of different models, whatever it is that your products are, and you would like to kind of test, compare, check how they complement each other, then you can use the tool for something like that. It's possible to combine the virtual and real components. So in theory, you could create a test and optimal variant of your desired components even before you start considering its design. So you could kind of sit down and say, I don't know, I want this component to do so and so. You can model it in this co-simulation environment. and you can test how the whole of your system, or maybe system of your systems, would perform if that component was created, if it was actually there in reality. And then it also, the platform enables the linking of different model libraries and their synchronization across the design process. One application could be determining the ideal servicing time of the ideal time for firmware updates. So basically, this would be kind of, you do some data analysis, and then you can try to understand when it is the right time to do an update of your firmware on your devices. And that way, you're kind of also you're enabling to front load your tasks to an earlier stages of the development process, and so you're creating the development efficiency. So in principle, I did a high-level overview, and I kind of dipped into the components itself. There's a lot more to it. Feel free to read. Feel free to ask questions afterwards. Send an email, or you can basically drop into the live help desk. And I would like to conclude here and pass back to Alice. Thank you very much for your attention.
Thank you very much, Omar, for this presentation. So, as Omar said, you have access to the question box, so you can ask your questions in the chat box. You can contact Omar directly. You have his contact details on the website, or you can also pop into the live help desk, which takes place every Thursday afternoon at 3:30. So now I'll give the floor to Jure from the University of Ljubljana, who is going to present, and I will give you the control as well, Jure.
Thank you, Alice. Thank you for the introduction. So yes, hello to all the participants. This is Jure Trilar from Faculty of Electrical Engineering of Ljubljana, representing the university. And our Digital Innovation Hub has some technical offers with potentials to be integrated to your CPS, Cyber Physical System Solutions. And I will try to make this brief. Okay, do I have the control? Okay, okay, I guess I do. Okay, so the first offer would be Percipio Big Data Analytics tool. The promise of this tool is that clients will not overlook relevant information, but will get a constant edge to overcome the blind spot problems, which is the problem of nearly all companies. They mostly focus on their existing business models, and quite often drives the executives and the decision makers to overlook the future opportunities and risks. This tool combines different sources of information, and with its algorithms wants to provide a holistic picture about both scientific and technical developments, as well as big trends that are of high relevance for current and future business development. In the current form of this analytics tool, and of course it can be customized to meet specific needs of clients, but in the current version, the database contains more than 250 million of technical and scientific articles, on top of more than 1 million of relevant social and news items per day. All these data are summarized into a few dashboards using some context-based analytics algorithms, and this context is selected by the customer or by the user. Moving on, this sweater, it's electrical switch with Ethereum blockchain support. It's a functioning blockchain prototyping kit, yet it can be extended to all kinds of use cases. This is, well, how to describe it, is blockchain-based end-to-end prototype comprised of IoT devices, sensors, and of course decentralized applications and user interfaces. In most popular use case demonstration, it enables control of electric switch with Ethereum blockchain transactions, and so the users can reserve electric charging slots and pay for the consumed time or energy through the Ethereum networks. It's just the latest practical application of blockchain technologies in IoT devices, and it consists of smart contracts developed and deployed on Ethereum network, and user and administration web interfaces, and of course the hardware device which intercepts the events from the network and toggles its states accordingly. Of course, like mentioned, this solution enables several use case approach models, and it's very customizable with on and off chain elements. It can be easily extended not only for the charging of electric vehicles, but also other arbitrary control of IoT devices and device-to-device transactions and interactions. Moving on. This is actually more of an innovation service. It's designing effective digital solution with relevant stakeholders. It's about creating innovative products, services, policies, and business models that correspond with relevant stakeholders' needs, expectations, and of course motivations, which can be mapped and used in both private and entrepreneurial ecosystems, and efforts to connect the business value to end users and public endeavors of creating sensible solutions for citizens. Service is named Zero Plus, and it's a methodology that combines social, economic, and also environmental return on investment with a component of open innovation. So for the last one, this is, I guess, most technical and most developed or by us. So it's IoT prototyping platform and consulting on this technical domain. We provide consulting and guidance in specific IoT sensor platform developments for real-life applications, and we can also support some predictive modeling, data sharing scenarios for direct commercial purposes. Usually, this includes commercially viable sensors and platforms, and our expertise in developing this market-ready solution offer great customization capabilities. Typical use cases would involve developing smart cities, smart agriculture, smart industry, and other application prototypes in fast and effective manner. And we, of course, have to implement tailor-made use cases that are defined by high level of customizability and, of course, meaningful data processing to add value of proprietary software applications. From University of Ljubljana, in this open call, this is all. Unfortunately, I will not be able to join you on the Q&A section, but I will ask Alice if she can share my email, and you can reach me directly via this email, and I will be able to answer all of your questions. So thank you for listening, and back to you, Alice.
Thank you very much, Jure. So you've heard Jure. You won't have the opportunity to get the real-time answers to your questions if you have questions on these technologies. But don't worry, you have Jure's contact on the website, or you can also email me directly. Or if you have questions during this webinar, you can also put them in the question box, and I will address them to Jure, who will come back to you. Okay. So moving on, we are now going to hear about ST Microelectronics from Marcello Coppola and Antonio Lionetto. So Marcello and Antonio.
Okay.
Hi, Antonio. So I'll give you the control of the slides as well.
Okay. Good morning, everybody. I'm Antonio Lionetto from ST Italy, and my colleague Marcello Coppola from ST France is the proposition from ST in the project as DIGIFED as technology offer. The presentation is split in three parts. The first is related to a brief presentation of ST. And this is very important because ST is the provider of a solution, but is on device. and silicon device on base of his experience on manufacturing of silicon. Then we have the presentation of ST France technology offer that is related to STM32 microcontroller generally, and then the last presentation of ST Italy offer that is related to the sensor on the physical device that is required to implement a system. Okay, I start with this presentation. This work? Yes. Okay. Oh, sorry. Okay. ST. Okay, ST Microelectronics is among the world one of the largest semiconductor company, serving over 100,000 customer on the different application around the globe with revenue last years of 10.2 billions, and the previous years was 9.6 billion. And ST have the presence in worldwide presence, 46,000 on the employee in, and part of them, 8,100 are dedicated to the research and R&D activity. Respect to the 2019, we have more 700 people to work in R&D. And the ST, the group ST is involved in the DIGIFED project for respectively ST France that is based in Grenoble, yes, and ST Italy that is based in Catania, refer to this main site, where you can find our device. Okay, sorry. You find our device in our product because ST isn't the system provider in the market or the final product developer, but is the provider of a device that you find in several kind of product that you have in your hand, from mobile, from industry solution, robotics, and other think of a solution where product of ST is present. Okay, why? And fundamentally, we have the strategic focus on IoT solution addressing four market: automotive, industrial, personal electronic, communication equipment, consumer, and computer peripheral. The focus on IoT is strategic because IoT make any system able to leverage the internet and its ecosystem. But this is the same for cyber physical system and system of system solution. We are enabler for this kind of a solution, and to the exploiting, to allow the exploitation of the ecosystem. Okay. This slide shows the proposition on microcontroller that is not only a microcontroller and a microprocessor unit with secure solution and NFC. This means that the ST provides microcontroller 42 general purpose microcontroller and microprocessor, but still have a proposition in 8-bit general purpose microcontroller that is typically used in subsystem of automotive. And also we provide a secure solution for the authentication, for the protection of the data with a singular device or embedded in the microcontroller, and they provide the tag and memory, especially EEPROM, for support this kind of application where is required this kind of communication and interaction. Everything for the Internet of Things. On the left side, you have the proposition of ST Italy. On the center, the proposition of the ST France, generally speaking. To cope with the innovation trend, ST provide a set of advanced devices to cover the implementation flow from physical age, extreme physical age, from sensing, actuation, signal conditioning, power energy management, up to the final application in smart things, smart home, smart city, smart industry. And with the proposition of a microcontroller on the shape of a technology to support the appropriate development. Our product, you can find us in SmartThink solution for in which we have a proposition of device for the environmental recognition to manage the raw data into information, to connect interconnection and protect your data, and in the energy efficiency. This is the scheme of the smart system integration, in which we have raw data from sensing, and the micro and the knowledge is applied to obtain services, and the output and the actuation is the output of the system. And at the same time, we have to consider the energy, the efficiency of the energy for the device. This is the scheme of the smart system integration. We find our solution in smart industry. In smart industry, where the focus is to have a solution that is enable for smarter, efficient production, to introduce advantage in the production and lower the cost, and to have more flexibility in the production, more digitalization inside, and or to ensure the awareness of the environment that is able to support the man-machine interaction, autonomous machine, and other kind of solution that are incoming with the digitalization of the industry and environment. Instead, on the smart city and the smart home application, we have the proposition of a solution that is able to provide new services in the smart city, smart services in the smart city, as smart grid, intelligent adaptive light, smart building. And in smart home, we provide a solution that are able to enable to enjoy better your life and the quality, to improve the quality of the life with smart control of heating, air conditioning, or the smart appliance, and more energy efficient. And this is our application, our scope, the scope of our application in this field. Then, Marcello.
Yes, you can move to the next slide.
Okay.
So my name is Marcello Coppola. I'm working in ST Microelectronics. I'm based in ST Grenoble. Today I'm going to present you what is our offer in terms of microcontroller and microprocessor. In this picture, you see the huge list of microcontroller that we have introduced so far. So at the end, depends of the kind of application you are going to target we can provide the most appropriate low power and secure microcontroller can address your application. So what does it mean is if you're going to use any of these kind of device, we are going to support you during the application experiment, providing the necessary element and functional software in order to ramp up in a very easy, fast way your application. So next slide.
Take time. Okay.
Yes. Okay, don't worry. So, as I mentioned before, when you use our ST microelectronics, what we provide is the necessary software to develop your application, to configure your macro, to monitor, and so on. And then we have also embedded software solution able to address specific functionality on different market. Let's say we can have, for this, a software solution to address audio, we can have a software solution to address the cloud or the motor and so on. And then we have also some vertical application using also AI. All those tools putting here, you can download from free from our website, so you can use without any extra cost. In parallel, we provide also some link with the well-known cloud provider. So we have several examples of how you connect our macro to those cloud provider. And then we provide also several ways to use different connectivity. Those are spanning from ZigBee, Sigfox, LoRa, Thread, and so on. And then in order to speed up your application during the development, your demo during the application experiment, we provide what we call the flexible prototyping board. Those boards can allow you to concentrate to your application and really to have at the end of the application experiment something working with the high TRL level. In term, so next slide. So what I would like to highlight, because as you have understood, we have a huge list of processors we can propose to you. However, I would like just to focus in two processors. One is STM32MP1. This processor is a sort of microprocessor. In some way, you can use this in any industrial wellness consumer home application. This kind of processor for you is a sort of equivalent to the Raspberry Pi. So what you can do with Raspberry Pi is mainly doing this. What is nice in this processor, we combine the MCU with the MPU, so we have the combination to word. In fact, this is a multi-core processor where we have where you can run Linux, but at the same time you can run an RTOS in a specific MPU embedded in this processor. Next slide. As I mentioned before, you can have the combination the two words, so you have the real-time stack, you can have any real-time application, plus you can have also the Linux application. What is important when you use Linux, we support Trustdome. In this way, we guarantee the extra security at your application, especially when you are going to connect your application to the cloud. This is very important. Another important point that we have released recently is this X Linux AI package. With this package, you are able to write your AI application to support directly in this board. We support any kind of framework like next. Yes, if you click, and then we can see, Antonio. We support
Yes.
TensorFlow. We can support ARM neural network. We support OpenCV, Python, many other. What is also very interesting is you can combine this kind of device with the Coral from Google, and then you can make a really powerful AI. So if the MP1 is not able to accelerate enough your AI application, you can attach the Coral, and then you can increase the computation power of this platform. And this is very important because this opens you a very large set of application domain. Next slide. So the last chip I would like to talk with you is this new chip proposed by ST, what we call STM32WL. This is a chip, one single chip supporting LoRa. This is today at the moment unique chip where you embed the LoRa modem plus the microcontroller in one single solution. Next slide. And then this chip is very suitable for industrial IoT, smart agriculture, smart home. So you really apply in different domains. This is really one of the best-selling chip at the moment from ST. Because you can cut a lot of your BOM and then you have something very innovative. The chip is also could be single core or dual core, enabling you to span from a really simple application to very complex application. Next slide.
You're finished.
Yes, okay, go. I let you talk.
I believe not. Maybe you have the control. Next slide, Marcello, try.
No, you have the control. You need to click. Oh, okay.
Okay. ST Microelectronics Italy provide the access to the X Nucleo to work in synergy with the STM32 environment to support the development of advanced solution in a very large kind of application domain, and to make be able the functionality required to implement and test this advanced system solution from the idea and from your idea to provide a set of board stackable and at the building block to test and finalize your software, your application, and then you move in the integration phase of the board and in field test, and then you are able to provide the final product to the market. What this is an example of and summarize what is the proposition from ST France on my processing, or to use the proposition from ST France and ST Italy in to identify your need and the building block that is required to be staked together to have the solution. You don't need to write low-level software to interface each device. ST provide abstracted access to expansion board functionality through high-level API and with the sample application. This is a summary of the STM32 board that are available and is related, is not included as STM32WL solution that has been described by Marcello before. And but this is only to have the idea, the number of the board that is possible to use in this kind of for your application, and for sure you are able to fit to find the appropriate solution on microcontroller solution, mainstream, low power, high performance, high security microcontroller that you need for your application experiment, for your application. Yes. To have an overview of X nuclear family, incomplete overview, this kind of a board is related to the physical extreme age of the application with and are split in 5 main folder that are related to sense, connection, power drive, mover, actuation, and sludge, in which we can find a solution board for motion and environment sensor, proximity, microphone, Bluetooth communication, actuator, control, motor drive, or the other kind of solution that are required for the definition of your application experiment. And the scope, the aims is to provide the building block that can be plugged together for the fast prototyping of your idea. And you can have a software package. We can use a software package that are available on our site to support the implementation of several functionality. This is an example of it is possible to develop the wearable solution on bottom right, staking together STM32 nuclear board and battery management, Bluetooth connectivity and motion and environmental sensor together to finalize the software with our tool and then provide the final solution, very, very little solution. The advantage is to don't have need to work with the single device. You use the board in which are plugged, are embedded our device, and with the appropriate connection to be plugged into the STM32 nuclear boards. Other kind of solution are the ST eval board, ST evaluation board. This kind of board are provided to have the board and the tool to evaluate the feature and the performance of our specific product and addressing a specific application domain. And we have several kind of this kind of solution for sensor application on wearable board or sensor tile development kit, or for environment monitoring Blue Coin and the tracker. That this is only a few examples with what is possible to find inside in our website. And for the stable board are classified on power, LED light, monitor, motor control, and IoT. And for this, we published online the schematic, the full test, the schematic, the boom, the Gerber, to make it easier to reuse or to develop with our device the design of PCB and board. The board is listed on this kind of folder: power, LED light, power, and IoT, motor control and IoT. But you can find this solution on referring on the application, because sensors that are for consumer and don't are the same for the industrial application. And then this kind of solution are listed in website under application, kind of application. The diagram pie show the percentage of the proposition of ST in this kind of a solution. The largest Eastern power solution that is cover AC-DC converter or DC-DC converter, or the besting solution up to connectivity consumer, several kind of proposition, different proposition are in the site. This is the last presentation, last slide for our presentation. And you can find more detail in our site www.st.com, and if you need, you can send email to me and to Marcello for have the support in the definition of your application experiment, and to verify how is possible to support your application experiment in for your proposition. Okay. Thank you very much for the attention.
Thank you, Antonio. Thank you, Marcello. So I'll get the control back now. We have a few minutes for the questions. I had one that I answered in the chat, but just to let you know, you will have access to the slides. On the slides, you have the name of the presenter, the name of the companies, and all the details of the technologies. So everything will be available on the website. I sent everything to the website manager tonight, so you'll have access to the slides and the recordings. So I gave you a bit of information about the app again, but we don't need to go over this now. Don't forget that the rest of our technical offer, so the rest of the technology offer for DIGIFED will be presented on Tuesday at 10 a.m. So we will have ICARLAN and BME. If you have other questions, put them in the question box now. Otherwise, we can close the session because we've reached the end of the session. If you have other questions that have not been answered today by the presentations, you can contact all the technology providers. So all the details for everybody are on the website. Jure, who wasn't here today to answer your questions, is sent me his email address so that I can send it to you, every one of you. So you should be able to see it in the chat. So you have his email address, but don't worry, all the email addresses are on the website. Omar is with us today. He handles a help desk every Thursday afternoon at 3:30 p.m. So you can join this live help desk and ask your questions, and we can redirect you to the right person. And I see no more questions now. So unless any one of you, Marcello, Omar, or Antonio wants to add something, I think we can close this session.
That's fine from my side. Thank you very much for the session.
Thank you, Omar. Thank you, Antonio. Thank you, Marcello. And I hope to see you all next Tuesday for the rest of these technologies offers. Thank you, everyone. Bye-bye. Have a nice day.
Bye-bye.
Bye-bye.
Bye-bye.